So hi children, in that previous video we discussed about that worksheet problems 3a, all the problems related to intervals we discussed, no? So in this video we are going to discuss about that wavy curve method, that one only, the method of intervals. But before going to discuss about that method, why we have to use this method? Okay, so what is the use of this method? So by using this method we can find that intervals that inequations which are in the form of p of x by q of x is greater than or equals to 0, or p of x by q of x is less than or equals to 0. So children, up to now we discussed about that just p of x, one of the polynomial, or else they given directly factors. So after we can write that intervals. Okay, we know that open intervals, closed intervals already we discussed, no? But here by what is the use of this method, ma'am, means, so by using this method we can write that intervals. We can write that intervals of the inequations, that inequations also which are in the form of p of x by q of x. Okay, so here that inequations, just 2x plus 3 is an inequation. Okay, 2x plus 3 is greater than or equals to 0. This is one of the equation. This inequation is in the form of p of x only, no? Okay, but here 2x by 3 whole by 3x plus 4. For example, I am saying you that. So here 3x plus 4. Now this is in the form of p of x by q of x, which is greater than or equals to 0. So previous we discussed about that 2x plus 3 is greater than equals to 0, means we know that how to write that intervals. Now the inequations which are in the form of p of x by q of x, which is greater than equals to 0 or which is less than or equals to 0. Okay, did you understand children? That is the purpose of that using the method of intervals, which is also known as wavy curve method. So by using this method, how to find that intervals? Okay, so let us see that. So first see that here the inequation which is in the form of p of x by q of x is greater than or equals to 0. So first I am taking here positive values. Positive values means we know that x is greater than 0. X is greater than 0 refers that positive values. X is less than 0 refers that negative values. Okay, and x is equal to 0 means we know that x is equal to 0. Okay, so x is greater than or equals to, which means x value may be equals to 0 or greater than 0. Greater than 0 means all the positive values. And here x is less than or equals to 0 means x value may be equals to 0 or less than 0. So less than 0 means which values here? Negative values. Already we learned in the previous classes, right? So on the number line, left side of 0 all the negative values, right side of 0 all the positive values, we know that. Okay, so here x is equal to 0. Okay, so these are the conditions. Now see here, p of x by q of x, when it will be positive, here we have two conditions. What is that? Either p of x and q of x both are positive, then we will get as a resultant also positive. Why? Because the quotient of two positive values is always positive. And the quotient of, second condition is the quotient of two negative values. Okay, so either p of x and q of x also, negative values also we can take. Why? Because a by b, this is positive, we know that, greater than 0. And here minus a minus b. So minus a minus b, again we will get it as a by b only, no? Minus a minus b. So here we can consider that minus a minus b also greater than 0 only. A by b is greater than 0 and minus a by minus b also greater than 0. Why? Because the quotient of two positive values and the quotient of two negative values always positive. Okay, so that's why here the conditions are two conditions. One is either positive or both also negative. Okay, so here by observing this one, here we can say that the quotient of two positives always positive, and in the same way the product of two positives also always positive, no? Shall we write like that? Okay, so I am saying you that a by b is positive, then a into b also positive only, no? Why? Because here A and B are positive values. So the product of two positive values is always positive. And here minus A by minus B is greater than 0. So minus A into minus B is also greater than 0. Why? Because minus into minus is always positive, no? So that's why. So here I am saying you that A by B also written as A into B in these conditions. Why? Because here also positive values and here also positive values, no? So that's why. So instead of that A, B, here I taken that P of X and Q of X. So see here. So to find that intervals of the given inequations, we have some steps. So first step as write P of X by Q of X as P of X into Q of X. First in this form we have to write. Okay. So the next one is factorize P of X and Q of X. Okay, first we have to factorize it. Afterwards we have to check that finding roots. The next step is finding roots. Okay, after that draw a number line. And represent roots on it. Okay, what is the next step? Draw a number line and represent roots on it. So here finding roots, here we will get some roots, no? So those roots, first we have to draw the number line. On the number line we have to represent it. Okay, we have to mark that. So after that we have to check that powers, exponents of the given, exponents of that expressions. After that we have to check that exponents. Okay, I will explain you that stepwise. So next we have to check that exponents. So here exponent is odd and exponent is even. So here we can observe that even exponents and odd exponents, no? So if that exponent is odd, then we have to change the sign. We have to change the sign. And here if it is even, no need to change the sign. Same sign we have to repeat. Okay, we have to write that same sign. So children, these all are that steps. Okay, so the first step is we have to write that P of X by Q of X as P of X into Q of X form. And here factorize P of X and Q of X. Next we have to find that finding roots. Next, draw a number line and represent roots on it. Okay, next exponents, we have to check that exponents. If the exponents are odd powers, then we have to change the sign. Next, if the exponents are even, then no need to change the sign. Okay, so let us say that. So I'll tell you one example here. So children, see here the next example. Let f of x is equal to x minus 3, x plus 2, x plus 5 by x plus 1 into x minus 7. Okay, so this is greater than 0. The condition is here greater than 0. Okay, so here how to check that? See, the first step what we discussed here. First step is write P of X by Q of X. So here this is in the form of P of X by Q of X only, no? Okay, so this one first we have to write in the form of P of X into Q of X. So x minus 3 into x plus 2 into x plus 5 and here into x plus 1, x minus 7 is greater than 0. First we have to write in that form, and here see, next one we need to find that, and the next step is find the, first factorize it. Okay, but here already they only given that factorization. After factorization only they given that expression. Okay, here x into x into x. So here we can observe that this is the cubic polynomial. So x into x into x is x cube. So that form not given, no. So just after factorization only they given that x minus 3, x plus 2, x plus 5, x plus 1, x minus 7. Okay, so directly they only after factorization they given like this. So first we can write this one as the p of x into q of x form. Next we need to find that roots. We need to find the roots, the next step. So x minus 3 is equal to 0. So here x is equal to 3. Clear? Next, x plus 2 is equal to 0. How to find that roots? Already we know that roots, right? Zeros of the polynomial. So from this one x is equal to minus 2 and here x plus 5 is equal to 0. So from this one x is equal to minus 5. Next, x plus 1 is equal to 0. So x is equal to, yes, tell me the answer, that is minus 1. And here x minus 7 is equal to 0. So from this one x is equal to 7. So these all are that roots of that given polynomials. Roots of that given polynomials. So here x is equal to 3, minus 2, minus 5, minus 1, 7. So how many values we got here? 5 values, because they given here after factorization they given here 5 expressions. So we are getting here 5 roots. Okay, so about that p of x 3 roots and q of x 2 roots we got here. Okay, into. So next what they are asking, draw that number line. So draw a number line. Okay, we know that number line, right? So here just to point out that values. So plus 3, minus 2, minus 5, minus 1, 7. Okay, so what are the values? Plus 3, minus 2, minus 5, minus 1, 3, minus 2, minus 5, minus 1, 7. Okay, these are the values. Now just represent those values on the number line. Here minus 1. So first I am representing here minus 1. Next to minus 5. So sorry, next to minus 2. Next to minus, okay, minus 5. Any other value not given, no, in that middle. So after that positive values. So here the positive first value is 3 and the next value is 7. Okay, so this is the representation. So after that representation, so again I am drawing the same thing here, just observe that. Minus 1, 3, 7, minus 2, minus 5. So by using this number line, how to write that intervals, I will tell you. See here, after that last digit on the number line, the last number on the number line, what is the last number here? 7. So right side of 7, all the values always positive. Why? Because here minus 1 after 3, next to 7. So while you are moving right side on the number line, we will get that positive values or negative values. Positive values only, no? And already we know one of the point. What is that? While you are moving right side on the number line, the number value should be in increasing order. Increasing order means plus or minus? Plus only, no? So that's why here this is positive. So here after 7 always positive. After 7 always positive. Not only 7. For example, here 5 will come, the last digit 5 after always positive. So that's why I am saying you that on the number line, the right side of that, the last digit on the number line is always positive. Okay, that is fixed. So here onwards we have to check. Okay, so here onwards we have to cross that one by one through that left side. Okay, so first number, what is the first number? That is 7. So I want to cross that 7. So here which sign we have to write? Which sign we have to write means, just observe that while you are crossing that 7, you have to check that 7 expression. Actually 7, that is the root of x minus 7 only, no? That is the root of x minus 7. So I will write here that expressions also. I will write here that expressions. Here x minus 5, that is the root of x plus 5. Okay, and x minus 2. So that is the root of x plus 2, x minus 1. So x plus 1, and here x minus 3, x minus 7. Actually these expressions only now given here. X plus 5, x minus 3, x plus 2, x plus 5, x plus 1, x minus 7. Okay, so those values only I written here. Now all the exponents of the expressions. So here the exponent is 1, here also 1, here also 1, 1, 1. So all the factors here having exponents as 1 only, no? So 1 means odd exponent or even exponent. So after this step, what is it? After drawing the number line, after representation the roots on the number line, we have to check that exponents. Okay, so here we have to check that exponents. What is the exponent here? 1. So 1 is odd exponent or even exponent? Odd exponent only, no? So odd exponent means we have to change the sign or is same sign. If it is odd exponent, 1 is odd, so we have to change the sign. We have to change the sign. So keep that point in your brain. So see here. So change the sign means here plus is there. So what will come here? Minus. Okay, why? Because here exponent is 1. So that's why. Next, while you are crossing 3, just you have to check this sign. So 3 means here exponent 3. So x minus 3. 3 is the root of x minus 3. So what is the exponent again here? 1. So again 1 only, no? So 1 means odd power. So odd power means again we have to change the sign or same sign. Change the sign. So minus is there. So here plus. Okay. Next. After while you are crossing minus 1. So while you are crossing minus 1, you have to check that minus 1. So minus 1 is the root of x plus 1. Okay. So x plus 1 here power is again 1. Okay. So power is 1 means again odd power. So we have to change the sign or same sign. Odd power means we have to change the sign. So plus is there means minus. Okay. So again minus 2. So here also power is 1. So that's why again need to change the sign. So here minus is there, no? So that's why plus. Next here plus is there. So that's why minus. Why? Because minus 5. Again power is 1. Okay. Again power is 1. So that's why all are that odd powers and same powers. Odd powers only, no? So that's why here changing the sign. Okay. So first sign always constant, that is positive. So positive after this signs, changing the sign or same sign, that is depends on that exponents. Okay. For example here 2 is there. Okay. 2 is there means exponent is 2, which means that is even power. So even power means here plus is there. Even power means no need to change the sign. So here plus is there means here also plus will come. Okay. And here some other even power is there means again that preceding, that before which sign is there, the same sign should be will come in that after completion of that, after crossing that number. Okay. So let us see that. Here the exponent is 1. Now what they are asking? So here the question is x minus 3, x plus 2, x plus 5. X minus 3 into x plus 2 into x plus 5. That is p of x whole by x plus 1 into x minus 7. The previous question again I written here. So here the condition is greater than 0. Condition is greater than 0. Previous already I told you that greater than 0 means which values? Positive values or negative values? Positive values. So in between which two numbers we are having positive sign? In between which two values we are having positive sign? Those values we can write here as intervals. Did you understand that? So here f of x is equal to, here what we have to write? Greater than 0 we written, no? So positive values. So after that infinity only, no? So here this is one of the positive value. Next, where we have that another positive. In between minus 1 and 3 we have that positive sign. So this is one of the interval. Next, here negative sign is there, no need to check that. Here positive sign is there. So positive sign is there in between minus 5 and minus 2. Okay. So how to write that means? So first interval is minus 5 comma minus 2 union. Next interval minus 2 minus 1 not there. Why? Because in between here minus symbol is there, no? So that's why we should not take. Next minus 1 and plus 3. Minus 1 comma plus 3. Okay. So after that here 3 and 7, that interval we should not write. Why? Because here negative sign is there. So we should not take. Next is 7 after plus up to infinity. Okay. So union 7 comma infinity. Understand how to write? Union means that values also there. Already we learnt in that sets concept, right? Union. Okay. So what is that? F of x. So f of x is greater than 0. Then the intervals are minus 5 comma minus 2 union minus 1 comma 3 union 7 comma infinity. Okay, that is for greater than or equals to 0, greater than 0. For example, here f of x is less than 0. Just another example I am telling you that here greater than 0 they given up. For example, that is less than 0. Then how to write that intervals? See here. Less than 0 means negative signs we have to check that. So where we have that negative sign? Here we have that. Here we have that negative sign. So minus 5 up to infinity, minus infinity. Okay. Why? Because here negative sign is there. And here also negative sign is there. Minus 2 and minus 1. Okay. Next 3 and minus 7. Is there any other where? Not there, no. So see here negative values. So minus infinity to minus 5 union. Next here positive is there, no. So we should not take that. Minus 2 to minus 1. Minus 2 to minus 1 union. And here minus, next where we have the negative here 3 to 7. 3 comma 7. Okay. 7 after we should not take. Why? Because 7 after we have that positive values, no. So that's why we should not take. Understand? So this is the way of writing intervals, which in equations which are in the form of P of x by Q of x. So these are all the steps we have to follow that. Okay. So depends on this one only. We have that one of the problem they given in worksheet 3. At that time I told you that I will explain you this problem. After explaining that wavy curve method, I said no. So in this video I will explain you that. See here. Yes, see here children. So this question, how to simplify that? X minus 3 into x minus 5. X minus 3 into x minus 5 is greater than 0 condition. Okay. So by using that wavy curve method, how to find this one? See here. So first we need to find that factors, roots, no. So x minus 3 is equal to 0, then x is equals to 3. Next x minus 5 is equal to 0, then x is equals to 5. So plus 3 and plus 5 are the roots. Now here we have to draw a number line. Okay. So on the number line, what are the values we have to represent? Roots. First 3 will come, next 5 will come. 2 roots only, no. Why? Because here 2 expressions only given. Which means 2 expressions given means that is a quadratic equation or quadratic expression. Okay. So 3 and 5. What I told you that after that 5 always positive only. Okay. Right side of 5 always positive. And here we need to change the sign or not. That is depends on that powers only, no. So to cross that 5, we have to check that x plus x minus 5. So x minus 5 power is 1. X minus 5 whole power 1. Only one time only there, x minus 5. So power is 1 means odd power or even power? Odd power only, no. So odd power means we have to change the sign or no need to change the sign? Yes, we have to change the sign. So plus is there, no. So that's why that is minus. Okay. Next. Here again to cross that 3, again we have to check that x minus 3. So here exponent is again 1. X minus 3 only one time is there. Okay. So 1 means again odd power. Odd power means we have to change the sign. So plus minus plus. Clear? Now what they are asking here? X minus 3 and here x minus 5 greater than 0. Greater than 0 means positive values or negative values? Yes, positive values. So positive values, here we have that positive value, here we have that positive value. Okay. So here we can write this one as 5 comma infinity. and here we can write that minus infinity to 3. Okay, so x value they given like this, no? So we can write that less than 3. Before that 3 means less than 3. Left side we are going means left side if you will move on the number line, then the number value becomes decreasing. Okay, so decreasing order, increasing, decreasing only, no? So that's why here this is x is less than 3, and here 5 plus, so on that right side that is greater than only, no? So x is greater than 5. Okay, x is greater than 5 and less than 3. Okay, so which option is correct? Yes, x is less than 3. This is x is lies in between 3 and 5. Here x value not there. In between 3 and 5 x value not there. After that 5 x value is there, and before that 3 we have that x values. So first option is wrong. And the next one, x is less than 3, satisfying, and x is less than 5 means, as x is less than 5 means 4 also will come. But here 4 is not there, and in between we have the negative interval, not positive interval. So we should not take that 3 to 5 interval. Okay, so that's why this is also wrong. So what is the next one? X is from x such that x is less than 3, clear, x is greater than 5. Okay, so which option is correct here? Option C is correct. Okay children, so by using this method we can find that we can write that intervals of that inequations which are in the form of P of x by Q of x is greater than or equals to 0 or less than or equals to 0. So maybe you may have the doubt, madam, here greater than or equals to 0 and less than or equals to 0 conditions there, no? But you explained that greater than 0 and less than 0. So here how to take that? Here I will explain you that. See here, x minus 3, x minus 5. So first I am going to take this condition, greater than or equals to 0. Okay, maybe those two are equals to zeros also. Okay, so that's why at that cases we have to include that 3 and 5. Okay, so set of 3 and 5 also we can include that. And in the same way, here less than or equals to 0. Less than or equals to 0 means here the condition is less than condition. 3 to 5 only, no? Less than condition. So we have to include that. So after that values also we can include here. Okay, less than or equals to 0. In between values also we can include. Okay children, so this is about that wavy curve method. So by using this method we have that self practice test in your material. So once check that all the problems. If you have any doubt, just comment me in that comment section. I will explain you in that next video. Okay children, so up to here your first concept basic maths completed. So in that next video again we will meet with second concept, compound angles. That is also very useful concept from that trigonometry. Okay, thank you all.